felt a cleaving in my mind, as if my brain had split. I tried to match it seam by seam, but could not make them fit. The thought behind I strove to join unto the thought before, but sequence raveled out of sound, like balls upon a floor. The teenage brain. By the second decade of life, the human brain is full size. It's billions of neurons all in place. But it is not yet finished.
The brain is a work in progress, and adolescence is the last great time of enormous brain change and brain development.
Now the drama of brain development focuses on the part of the brain that makes us uniquely human, the still maturing prefrontal cortex.
The prefrontal cortex is a part of the brain that allows us to make future plans, and that's involved in such highly abstract areas as personal responsibility, morality, and self-control. This part of the brain is undergoing this major step in maturation during adolescence.
With the part of the brain responsible for reason, judgment, and self-discipline still developing, it is no wonder that the teenage years can be a time of turmoil and confusion.
The adolescent's brain is clumsy because all of a sudden there's these new parts of their brain that are online that are doing tasks and they're getting used to it. They are trying to figure out, okay, I've got a frontal cortex, what do I do with it?
The developing teenage brain is in flux, shaping personality, behavior, even identity itself. As the brain matures, the teenager also faces special risks, from addictive drugs and alcohol that can hijack the brain to the chaos of schizophrenia that strikes most often during adolescence. Sometimes the teenage brain fails in ways that challenge even our most advanced understanding of how it works. 2 years ago, Courtney Hale Cook was a senior in high school when he was struck by schizophrenia, a brain disease to which adolescents are particularly vulnerable.
You know, I spent, up to that point, I had spent 19 years, you know, with virtually the same personality. And I was very accustomed to it, and I liked it. I liked being me, you know? And all of a sudden it was taken away.
He would come up to me and he would say, "Mom, you look like a really old lady today." And he said, he would point to my eyes and he'd say, "You have a black hole here and a black hole there." Or he would describe things as going into tunnel vision so that everything else is black except what was in that small tunnel at the end. When he would open his eyes in the morning, he would see gnats, he would see sparkles. Not even with the first thought of the day, just the minute the eyes were open, he would have all these visual disturbances.
They're usually in the very center of my vision. But it varies. Like now, they're kind of just wherever I see the sky. You know, they're still there.
I think it took him a number of weeks to come to me and say, "You know, Mom, I've seen this in psych class, and Mom, I'm really terrified. I'm really scared that I have schizophrenia."
I felt like I was going crazy. And, you know, I felt like I'm going to be crazy for the rest of my life.
It's hard for me to imagine a disease that is crueler than schizophrenia. I mean, when does it begin? You know, in late adolescence and early 20s, just when a family and society have their maximal investment in a young person, just when, you know, they're about to graduate high school or college. And this child is lost in the most awful way.
At the University of Iowa, Courtney is part of a research study that is investigating how schizophrenic brains function and malfunction.
We'll put the bonnet on.
Schizophrenia is as complex as the brain itself, and clues to its biology have been stubbornly elusive.
Schizophrenia is definitely an enigma. It's never been possible to identify an obvious disease-related feature that distinguishes schizophrenia from all other conditions. You look at a brain of a patient with schizophrenia under a microscope, you don't see anything that would make you say, aha, this is a disorder of these cells or those cells.
What has gone wrong inside the brain of someone suffering from schizophrenia? For centuries, the answer has eluded researchers. But new imaging technologies have revealed how the brain fails to function properly. Focusing attention on several different brain regions that are underperforming. Regions responsible for thinking and reasoning, memory, and emotion. The fact that so many regions are malfunctioning has led researchers to investigate a part of the brain which coordinates their operation, the prefrontal cortex.
There's certainly a lot of evidence that the prefrontal cortex functions like the conductor in an orchestra, and that it maintains harmony and it makes music out of many, many disparate elements of this orchestration. And that we think that part of the problem when the frontal cortex is deficient, as it may be in schizophrenia, is that instead of music, there's noise.
One of the things that happened to me was that I was constantly like stupefied, and I do have a little bit of trouble staying coherent, staying to one particular subject, you know, because my mind is somewhere else.
This time I want you to tell me the color of the ink. Ignore what the word says and tell me the ink. Red, blue, brown. Okay?
All right.
As quickly as you can. Ready? Go.
Red, blue, brown, red, green, blue, brown, brown.
A poorly functioning
blue,
prefrontal
red,
cortex
blue, red,
makes
green,
thinking difficult.
brown, blue,
It is no surprise that many people with schizophrenia don't perform well on a series of tests designed to measure their ability to think and reason clearly.
red, blue.
Courtney was once a good student, but as the disease progressed, his grades began to drop, and he finally had to put off plans for college.
Schizophrenia is a disease that affects the highest human functions, the parts of us that are most evolutionarily advanced, our ability to think at high conceptual levels.
Scientists had once hoped that MRI images of the brain would help solve the mysteries of schizophrenia by identifying damage to specific brain structures. Instead, the images revealed a new mystery.
We were surprised to see that there was no obvious hole in the head. But what there was that the ventricles of the brain, which are these centers in the brain that have spinal fluid, water in them, that are just cavities, were slightly bigger in patients with schizophrenia.
Why were the ventricles, reservoirs of fluid that cushion the brain's delicate tissue, larger in schizophrenia? The oversized ventricles proved to be evidence that other areas of the brain were smaller.
Your skull is made of hard bones that does not expand. So if the ventricles, these cavities, got bigger, the only way all this could stay inside your skull was that something else had to get smaller. And there have been a lot of studies subsequently showing that there is a slight, very slight, thinning of the surface of the brain, the cortex, probably that accounts for these changes in the ventricles.
Once again, evidence pointed to a connection between damage in the prefrontal cortex and schizophrenia, which may help explain why the disease appears most often during adolescence.
How can I trust you when I know what you've done?
Baby, please believe that all that is done.
If I decide to go along,
I promise I won't do you wrong.
Researchers are now looking more closely at developments in the normal adolescent brain for clues to what might trigger the onset of schizophrenia.
The adolescent brain is far more flexible, far more adaptable than we had ever realized before. There's enormous potential for change, and not just change in sort of psychological dimensions, but actual physical, anatomical changes.
At the beginning of adolescence, the prefrontal cortex goes through a burst of growth as neurons reach out to connect to other neurons, much as they do throughout the brain during early childhood. And just as in children, the connections between neurons in the teenage brain grow stronger, or they are pruned back and wither away.
Sort of nature's way of making sure that the connections that do survive are hardy and robust. One of the ways the brain seems to try to figure out which connections to keep and which ones to eliminate or prune is based on the activities of the teen. The brain is searching for, what am I going to need to be good at to survive in this environment? And the way that it figures that out is, what am I doing now?
Adolescence could be characterized as a stressful time for the brain. There are chemical changes, hormonal changes, anatomical changes, changes in the expression of genes inside of cells. It's a time of great biological tumult. And the frontal lobe is fighting to adapt to the environment, to deal with all these inner instinctual surges. It's difficult. It's difficult with a frontal lobe that's normal to make it through adolescence. But we believe that patients with schizophrenia don't have a frontal lobe that's normal. We believe it didn't develop normally, probably from early in life.
Are there clues to schizophrenia in childhood that may explain the brain's later failure during adolescence? Can the child's brain be hiding within it the seeds of its own later malfunction? Psychologist Elaine Walker is trying to answer those questions by examining the home movies of children who later developed schizophrenia.
We were looking for evidence that there was some abnormality in brain function. And of course, one of the best places to look for that in young children is in their motor development. This child only uses one hand to try to catch the ball. This child is showing some unusual posturing of his left hand, hyperextension of his fingers. Normal children develop crawling in a symmetric fashion. This is a very asymmetric crawling pattern, and that is another characteristic that we observed more often in the children who later developed schizophrenia.
Walker's observations cannot be used to predict schizophrenia. Although these eccentric movements appear more frequently in children who eventually develop the disease, they can be found in normal children as well. But Walker's study is consistent with the theory that schizophrenia is caused by events in early brain development, even, perhaps, just months after conception. As neurons are born, take their place in the developing brain, and then join one another in an intricate network of connections, scientists see the possibility for error. The genetic makeup of the brain itself, poor nutrition during pregnancy, or a viral infection, all may have devastating effects. Whatever the cause, scientists speculate the damage lies dormant until adolescence, when the prefrontal cortex goes through its final maturation.
Schizophrenia could be a disease in which this last developmental stage is run amok, and we end up literally with the wrong connections in the brain.
Courtney, we're going to bring a monitor over in front of you that you'll be viewing throughout the study.
Okay.
Schizophrenia disrupts not only the thinking parts of the brain, but it can also have a severe impact on the emotions.
Courtney, next you'll be viewing some slides that most people find to be pleasant or positive in content. Just relax and watch.
To probe the emotional regions of the brain, researchers flash a series of pictures on a screen and use advanced imaging technologies to watch the brain's response. The normal brain responds to these stimulating images by activating regions of the brain that process emotions. These same regions respond poorly in many people with schizophrenia.
People with schizophrenia will very often say, I've lost the capacity to feel related to other people in the world, or even related to the world at all. It's both an intellectual emptiness and an emotional emptiness. And it's one of the factors that drives people with schizophrenia to feel like taking their lives, to feel like committing suicide, because they feel as if they've lost themselves.
The thing that really crushed me was the lack of motivation, the negative symptoms of schizophrenia, the flat affect, the emotionlessness, the apathy. Those were the things that really got to me.
He would talk frequently about not being able to feel anything. He could feel no sorrow. He could feel no joy. There was just nothing there. No sorrow, just empty. That's what he would describe, just empty and black.
I didn't want to live the life that I'd been given anymore. It was so contrary to what I wanted that I didn't want it anymore.
When I heard that Courtney had attempted suicide, I was not surprised. He had talked about it, he has had ideas about suicide, and he's one of those individuals that understands he has an illness and it's not likely to go away. That he hadn't succeeded was perhaps what surprised me the most, because he succeeds in most things that he's done in life up to this schizophrenia.
I wrote in my suicide note that why take death seriously if the quality of life is poor? And that thought really stuck with me for a long time.
While schizophrenia has stolen Courtney's emotional life, other teenagers with schizophrenia suffer from hallucinations as well. Frightening visions and voices that do not exist.
June 17, 2000. Dear Diary, it's been strange. It wasn't a good day. I'm so depressed, I hate myself. Things would be better if, well, you know, gotta go now. Love, Sabrina Yeskel.
Sabrina Yeskel was an excited 12-year-old when she first went off to sleepaway camp. Once there, she began to hear voices.
They were loud. The tone of voice was a deep, heavy-set voice. They've said to kill yourself. They've said, I'm not worth living.
Sabrina's mother rushed to camp, but barely recognized her daughter.
She started screaming, stop. And I said, what, Sabrina? What's going on? She said, he's trying to kill me. So I pulled off the road, tried to hold her and tell her everything was okay. We made it home, but she came in the house screaming. The man was following her everywhere, and he was trying to choke her.
Sabrina was diagnosed with schizophrenia. Now 14, she has been struggling for 2 years to stay in touch with reality. She still hears threatening voices, and hallucinations haunt her waking hours.
Sabrina often sees a black hooded dressed figure that sometimes will just stare at her, sometimes it talks to her, sometimes it tries to touch her, sometimes it tries to kill her. Sometimes when she's struggling with this, they begin almost chanting, "Kill yourself, do it, do it, do it."
Come on in.
All right.
Have a seat.
At the University of North Carolina, researchers are investigating how hallucinations can overwhelm the adolescent brain, and they are testing new drugs to help treat these psychotic symptoms.
Could you look right at that keyhole over there? I'm going to check your eyes out, if that's okay. You just look
Isaac
straight
Wallace
ahead.
began to hear voices when he first went off to college. As the voices grew more frightening and his thoughts more paranoid, he was finally hospitalized for his own protection.
When Isaac walked in the hospital, he was completely wrapped up in hallucinatory experiences he was having, the voices he was hearing, the beliefs he had developed to explain the voices.
Whenever I'd hear voices, I just completely block out what was in the real world and just think about what the voices were saying and talk to them.
The voices that Isaac heard were disturbing because they appeared so real. Yet they were produced by his own flawed brain.
When you see psychosis, you realize that we don't hear with our ears. We hear with our brain. We don't see with our eyes, we see with our brain. And so when the brain misfires, you can have experiences of hearing voices that sound just like they're coming from outside your head.
In the normal brain, waves of sound falling on the ear travel as electrical and chemical pulses to the hearing part of the brain, the auditory cortex, generating a surge of signals that travel to the thinking regions of the brain where they are interpreted. Scientists believe that in psychosis, the thinking regions fail. Neurons misfire in random and chaotic ways, creating sounds that have no connection to the outside world. The result? A perception of sounds that do not exist.
So when the brain misfires, when the circuitry in your brain is out of whack, it'll be just as if you're hearing the radio on.
Scientists theorize that psychosis is caused in part by problems with a chemical in the brain called dopamine, one of the brain's neurotransmitters, molecules that send messages from cell to cell across a tiny gap, the synapse. In the normal brain, dopamine acts by stimulating receptors on the neuron that is its target, setting off a cascade of electrical and chemical reactions. In the psychotic brain, for reasons that scientists are still trying to understand, the levels of dopamine surge, overstimulating the receptors, wreaking havoc with the brain's ability to send clear and accurate signals. Since the 1950s, antipsychotic medications have been standard treatment for relieving psychosis. For Isaac, they have worked wonders.
I'd say within 3 weeks, the voices really, they dropped maybe in half to maybe 75% less than what I was hearing. Yeah, it has brought me out of, my own little world and, brought me back into reality. I can hold a job now, and I think I can go back to school as well because my memory's back and my concentration is back. I think I might do better than I did before.
Antipsychotic medications relieve psychosis by reducing the impact of dopamine on the neuron by clogging dopamine-sensitive receptors. With diminished neuronal stimulation, psychotic symptoms lessen and often disappear.
We were lucky. We found the right medicine for Isaac. And at this point, I think he's had a almost complete recovery. He's back to his old self, his old Isaac.
Antipsychotic medications don't cure schizophrenia, and Isaac will need to take them for the rest of his life. But in some people, the drugs don't work at all. Schizophrenia varies from person to person, and Sabrina has a more resistant form of the disease.
When Sabrina first became seriously sick 2 years ago, it seemed like we had 100 possible medicines to try, and certainly one of them would work. And yet, we discover that they haven't worked, and it's getting very scary because we don't have many left. And as a parent, it's incredibly difficult to watch your child suffer. But it's also, I see her courage, I really do. I see her fighting this every day, and I'm incredibly proud of her.
I'll remember it later. That's who taught me. It was my dad, and it was...
For Courtney, medications have helped him pull back from the emotional void he once faced. His thoughts of suicide have passed. He still struggles with his illness, but he is going on with his life and has recently entered college.
I'd rather have lived the life that I live right now, as confusing and painful as it has been, than to have never been born at all.
I think he has learned a lot about how fragile life is. I think he has learned a lot about what is really important.
Every year, 300,000 Americans are diagnosed with schizophrenia. Most of them first develop symptoms in their late teens. But millions more teenagers are vulnerable to another danger. Adolescence is a time of growing independence. As the prefrontal cortex matures, teenagers are beginning to explore the world on their own. But their judgment and reasoning are still not fully developed, which makes it especially risky when they experiment with addictive drugs and alcohol. 12.5 million American teenagers suffer from serious drug abuse problems or addiction.
Adolescence is a time when kids are exposed to all kinds of influences in the world, some of them terribly negative, like drugs of abuse. Addiction is a disease of the brain that affects thinking, emotion, and behavior. In that sense, it's like many other serious brain diseases, like depression, like schizophrenia. Only here, the pathogen are the drugs of abuse themselves, acting on a vulnerable brain.
I never thought that I would become an addict, or even thought about being an addict until I really started doing coke. And then it kind of dawned on me, I'm doing cocaine now. It's not just weed, it's not just alcohol, you know. This is getting worse and worse.
Jessie Galatar began experimenting with alcohol when she was 11. Marijuana followed shortly after, and then an array of other addictive drugs. By 16, she was addicted to cocaine.
She had to have it to function. She had to have it to get out of bed. She couldn't get out of bed without doing cocaine first. She couldn't walk into the school without having done cocaine in the parking lot. And it wasn't fun anymore. It was just, she had to do it to live.
I was just like, I've got to do something right now or I'm gonna die. Because I couldn't live like that anymore.
By 17, caught in a desperate obsession, Jessie checked into the Karen Foundation in eastern Pennsylvania, a residential drug rehab center.
Who else in here uses pot a lot?
Here, teenage addicts try to regain control over their lives that have been captured by addiction.
After a while, it was like, instead of me having the control over the drugs, it was like the drugs had control over me.
If I was sick, I was thinking about dope. If I was on dope,
I was thinking about how I'm gonna get it again. And like, that's all I thought about all the time.
One day I was sober, I didn't have anything to drink and nothing to smoke. And I realized it was the first day in a long time that I had no chemicals in my body. And it felt weird and I was irritated. And it was the worst day of my life.
You know, I've been here about a week now. I'm still not recovered. I still, every single day, want to smoke. And it's been a part of my life for so long. You know,
Addiction used to be viewed as simply a moral failing, a weakness of character.
I just love it so much.
But scientists have begun to investigate how addictive substances fundamentally change the brain, gradually taking control over motivation and desire. Addiction research has focused on the neural circuitry in the brain's reward pathway, the network of neurons where our desires arise. Flowing along this network, continuously stimulating our pleasures and appetites, are the neurotransmitters that one neuron uses to talk to another. Addictive drugs work by altering the level of these neurotransmitters and slyly capturing the reward pathway.
All addictive drugs are Trojan horses. Every single one of the chemicals that are addictive are mimics. That is, they look like a neurotransmitter. They look like one of the chemicals that the brain uses for nerve cells to communicate with one another.
Many addictive drugs mimic one of the most powerful neurotransmitters in the reward pathway, dopamine. In the normal brain, dopamine travels across the synapse, stimulates receptors on the target neuron, and then it is quickly reabsorbed by tiny molecular vacuum cleaners called dopamine transporters. But when cocaine is abused, trillions of cocaine molecules surge into the synapses, clogging the vacuum cleaners, artificially boosting the level of dopamine in the brain, producing a cocaine high.
Let's imagine a wonderful natural reward. You know, I go to a restaurant and have the best ice cream sundae I've ever had. You know, I'd have a certain amount of dopamine probably being released in my brain. But cocaine, which gets there chemically, gives your brain, gives these synapses more dopamine for a longer amount of time than it has ever experienced before.
Now, with the experience of your first drug high, particularly when it's cocaine and heroin, watch what happens. The dopamine levels ascend above and beyond those experienced with orgasm, above and beyond the greatest physiologic experience we can have as men and women.
I got so high, and I literally thought I was floating. I was just, da-da-da, going through, bumping into people and making jokes and laughing, and tears were rolling down my face. I was laughing so hard. And
after doing like 3 or 4, I'd just kind of sit back and light a cigarette, and it would just like fill me like completely, and like it was like taking me away from the world.
Once the drugs and the alcohol are introduced into the addicted brain, the natural system is what we call down-regulated. It means that the things that are supposed to work for exercise and food and all the things that are supposed to make us feel good, they basically go into hibernation.
You have a feeling of hopelessness, such that the only thing you can possibly do to have any semblance of pleasure in your life is to re-administer the drug.
The first high can be exhilarating, but after repeated drug abuse, a dark side to addiction begins to take its toll. The brain responds to the repeated use of cocaine and the dopamine surging in the synapse by fighting back, cutting away receptors on the neuron that are the dopamine's target. Without the receptors, dopamine can't stimulate the neuron, and the drug high is reduced. But so is enjoyment of all normal pleasures as well.
It tricks my brain, It made me think that, that I was happy, that I enjoyed my life, when in fact I really didn't. When I wasn't high, I hated my life.
I remember writing diary entries like, I was in pain, but I still want to do more, and I can't stop. And I just wanted to die all the time. I didn't even want to live anymore.
You know, none of these kids sat down and said, hey, I want to be a drug addict. Actually, what happened is, like lots of other adolescents, they played what turned out for them to be a game of Russian roulette. There was something about their genes, something about their temperament that made them vulnerable, so that when other kids got away, often scot-free, they got hooked. There was something different about their brains.
We've got some alcohol in here, and our job now is to help you to consume this beverage in about a 10-minute period.
Like cocaine, alcohol is dangerously addictive. By their senior year in high school, 9.5 million American teenagers will have tried it.
So, you've been watching the sports?
At the San Diego Veterans Hospital, Mark Shuckett is trying to understand what makes some of these teenagers more vulnerable to alcohol than others.
Oh, yeah, sure.
That's super. That's great.
For volunteers like 18-year-old Justin and 21-year-old Elika, Shuckett collapses one night of drinking into 10 minutes and then records the way their brains respond.
Alcohol has a huge impact on brain waves, and it is indeed one of the ways that one can measure how the brain is changing in the presence of alcohol or other drugs. We gave them equivalent amounts of alcohol per kilogram. The result of that was that their blood alcohol levels were virtually identical. What the brain waves show us is that Elika is responding more to the alcohol than Justin. Her brain waves are being impacted by the alcohol significantly more than Justin's brain waves are being affected. So on a 0 to 36 scale, how high do you feel?
36.
What do you think about the slurredness of your speech? Is your speech slurred?
I don't think so, but it's probably is. It's probably like 20.
Okay. And regarding how drunk or intoxicated you feel overall?
36.
And she was having difficulty concentrating, was having problems focusing on exactly what it was that we were talking about, and she had some pretty darn good insight that she was feeling pretty high. And on a 0 to 36 scale, how high, using that term generically, feeling high or intoxicated are you?
Nothing. I don't feel anything really, like maybe a 1.
And how about how clumsy you feel you might be?
Nah, 0.
And problems where you feel like you're floating?
0.
Got it. Justin had the same blood alcohol level, and when we asked him how he felt, he was basically saying, I don't feel much. It was almost close to 0, very low on the scale. And all you had to do was look at him and you knew that he was feeling less.
0.
The same blood alcohol level, very different reactions.
0.
The two people are starting out their drinking evenings with basically different equipment on board. Elika, after 1 or 2 drinks, is likely to look around and say, I'm getting pretty high, I'd better slow down. And a 0 to 36 Justin, scale, we would guess, when he goes to a party, just having a couple of drinks, he probably looks around and says, well, what's the big deal? And he's probably more likely to go on to 3, 4, or 5.
Yeah, 0 on that.
Justin gets drunk. It just takes Justin a lot more alcohol to get drunk than Elika.
Even though Justin's brain responds more slowly to alcohol, he is more likely than Elika to become an alcoholic. Because he is less aware of alcohol's powerful effect, he may keep drinking when Elika might stop, exposing his brain to ever higher levels of alcohol and increasing the chance that he will become addicted.
You know, I've talked to kids my age, my size, 6 beers and they're passed out. For me, 6 beers, I'm just starting to get warmed up. I can drink easily almost a case of beer to myself. You know, I have alcoholism in the family, you know, going back generations, and I'm sure that plays a major role. But it seemed like...
One of the major reasons why alcohol dependence is running in families is because people inherit genes that impact on how their brains function. We found that a low response to alcohol is associated with a high risk for alcoholism regardless of your family history. But if you have both, a family history of alcoholism and a low response to alcohol, your risk is really quite large.
Either 3 out of 4 or all 4 of my grandparents were alcoholics, which increases the probability of being an alcoholic. And like, it was just pretty much people who looked at me, even from when I was little, would tell me, you know, you're gonna be an alcoholic when you start drinking.
But once teenagers become hooked by alcohol and drugs, why can't they stop? How do drugs change the brain to make recovery so difficult for many and impossible for others? Edward Coleman began using marijuana when he was 13 and quickly advanced to abusing other drugs. By 19, he was a hardened cocaine addict, living on the edge, hustling and scamming to feed his all-consuming habit.
I can remember days, can't go to sleep from thinking about trying to get high. What can I do, or where can I go, or who can I rob to get money just to get high?
So we just have to get you positioned in the right way so that we can comfortably get up on the table here.
Dr. Anna Rose Childress has been studying drug addiction for over 2 decades.
You're going to see some videos, and they could be nature videos, or scary, or sexy, or drug-related. And
researchers have long observed that recovering addicts relapse most often when they return to their drug-using neighborhoods and friends. Childress wondered if it was these cues that somehow triggered an insatiable need for drugs in a brain changed by addiction.
Just the reminder of drug use, just seeing these friends, seeing a crack pipe, smelling the smell, creates this overwhelming sense of need, of craving, that the world is completely out of balance till I have some cocaine.
Childress devised a simple experiment. She scanned the brains of long-term cocaine addicts, but only after they'd been drug-free for 2 weeks. This would ensure that the images she captured were not cocaine's high, but more permanent changes to the brain. She showed her subjects a series of video images. First, nature scenes.
Starting from blossom to blossom, their lives depend on flowers. I cook it up because that way you can see what the comeback is, all right?
Then, images of explicit drug use.
You can only smell it, man. Good.
The 2 different videos produced very different activity in the addicts' brains. The scans during the nature video revealed very little brain activity. But when the videotape switched to drug use, the scans erupted in red, indicating intense brain activity.
We could see that the brain was doing something special and something different when a person was in a state of desire than when they weren't. It was extremely exciting for us because it was the first time really in all of human history that we'd been able to peek inside the brain during desire. And these are images that were done in the PET scanner that showed...
Childress had captured an image of how the brain had been fundamentally altered to produce a driving hunger for cocaine.
Well, our patients describe craving as the thing that can push them to do things that they never imagined that they would do, to cross their own rules, their own values, to put not only their relationships in jeopardy, or their possessions, or their jobs, but their very lives.
It's like being a victim of a vicious pit bull attack. Once the dog attacks you and locks onto you, he's not letting go. The only way to get him off is to kill him. And that's pretty much how I was looking at it. The only way to get out of drug addiction was to die.
Despite the craving carved into his brain, Coleman was able to beat his addiction. And he did it in a way that has intrigued researchers. Coleman's legs were a casualty of a stray bullet in his drug-filled neighborhood. But this tragedy allowed him to make a surprising discovery. He was still using cocaine, but to calm his paralyzed but trembling legs, he began taking the common muscle relaxant baclofen. When he ran out of cocaine, he was surprised to find he no longer needed it.
As long as I was taking the baclofen, it was blocking my mind from thinking that I needed the drugs. It was blocking that part of me that thought about it and wanted it.
The baclofen appeared to be overriding the craving for cocaine etched into his brain. When Coleman reported his observations to Childress, she was intrigued by this homegrown scientific experiment.
So we offered him a PET scan in our usual hummingbird video, cocaine video, with the bet that on baclofen that we wouldn't see the hot spots lighting up in these areas that are important for anticipating reward. Sure enough, look, there are no hot spots. So for you watching the nature video, your brain didn't respond very much differently when you were watching the cocaine video. His two scans are identical, so the way that he looks at the nature video, the way he looks during the cocaine video, there are no hot spots. So it's really encouraging to us that his description of how he feels, that he doesn't feel pulled and that he feels as though everything's in a manageable range, really matches up with his brain. His brain agrees.
Baclofen may prove to be the first medication to actually curb the insatiable desire for cocaine, and it is now in early testing on addicts. But until medications are available to fight addiction, addicts will continue to struggle to overcome addiction on their own. Jesse and these other teenagers will spend anywhere from between 3 weeks to 3 months reclaiming their lives. And they have learned important lessons about how drugs have changed their brains.
I'm sitting here and I'm really dwelling on the fact that I'm an addict and I need help, and I'm not going to be able to do this by myself, and I need to do all the things that they teach me, and it's really hard. It's really hard. It's scary.
The disheartening reality is that 8 out of 10 addicts who leave rehab relapse and return to their addiction, sometimes after months and even years of sobriety.
I'm still terrified of relapse and just starting to use again. And that's actually, it's kind of good because I'm less likely to go back out if I am scared to death of it.
You don't want it too tight, you just want it so the helmet's not moving around on you.
The last hurdle many of these teenagers will face before leaving rehab will be an aerial ropes course.
As you notice, there's 2 cables, one on each side, that suspend the ladder, the rungs, okay? You can't hold on to those. Okay. The only thing you can hold on to are those rungs and your partner.
This is not as easy as it looks.
Harnesses and that.
This graduation exercise symbolizes the challenge these teenagers face in beating their addictions after their brains have been distorted by drugs.
Pull, pull, pull. You got it, ladies. Nice job. Nice job.
A critical part of the brain has literally been hijacked by drugs of abuse. It's been rewired so that behavior is now focused on this life of obtaining and using drugs.
Communication is a key.
The behavior has become automatic, and the trick for the person who's recovering is to stop these automatic responses.
Look above you. What's above you? There you go.
What we attempt to do here is recruit other parts of your brain to diminish those improper messages. Knowing we can't eradicate them, we attempt to recruit other soldiers, all right, other parts of the brain to help diminish those feelings.
Stand up. Let go of the rope. Use your partner to stand up.
If I had to guess, what we have to shore up is the prefrontal cortex. The critical functions of this prefrontal cortex, what we call executive function, self-control, the ability to literally have responsibility for oneself. And we can do that because their whole brain has not been overthrown by drugs of abuse.
Liz, all you've got to do is reach up, okay? Grab on to Chrissy.
Don't pull yet.
I've got you here on the rope, too.
No, don't let go of my hand, Chrissy.
You got it.
My greatest fear, which is climbing, and I worked through my greatest fear. I could do anything. I could do anything.
Adolescence is one of probably the most demanding times in life. You're learning how to function as a human in society. You're beginning to try and form partnerships and long-lasting friendships. You're becoming sexually aware.
And we know that leaving home, becoming an adult, having a family requires a number of much more complicated mental, psychological abilities.
And the organ of all of these changes in the way people think and emote and make judgments is, after all, their brain.
Next time on The Secret Life of the Brain. Emotions and the adult brain.
Why do we have these emotions? What are they for?
There's no empathy or sympathy. He just can't get that feeling.
Deadness, terror, distorted time. I did not want to live.
Next time, the emotional brain. Take a 3D animated tour of the brain at PBS Online. Find brain teasers, take a cognitive test, and more at pbs.org. Major funding for The Secret Life of the Brain is provided by the National Science Foundation, America's investment in the future. Funding is also provided by...
At Pfizer, we're spending nearly $5 billion looking for the cures of the future. We have 12,000 scientists and health experts who firmly believe the only thing incurable is our passion. Pfizer, life is our life's work.
The Medtronic Foundation, on behalf of Medtronic, providing lifelong solutions for people with chronic disease. Medtronic, when life depends on medical technology.
The Park Foundation, dedicated to education and quality television. The Dana Foundation, the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.